Assalamualaikum and hi guys, this is the second video for subtopic 2.1 Bohr's atomic model. The first two learning outcome that we are going to look is to calculate the photon of energy emitted by an electron that produces a particular wavelength during transition. So you already learned in the first video that when the energy was emitted, there will be a photon, which is a light yang keluar when the electron move from higher energy level to lower energy level. So you are going to calculate the wavelength of this photon. The second learning outcome is perform calculation using Rydberg equations. There will be a formula which is we are going to call Rydberg equation. The amount of energy released by the electron is called a photon of energy. A photon of energy is emitted in the form of light with specific frequency and wavelength. Therefore, the energy change of an electron during transition can be related as delta E equal to Planck constant times frequency. Okay, you learn in the first video that when the electron move from different energy level, you can calculate the energy difference. You also learn that when the electron move from higher to lower energy level, the electron will release a light that we call a photon. This light has specific frequency and wavelength. So this formula showing the relationship between the delta E and also frequency. If you calculate the delta E, then you can find the frequency of that light. The value of Planck constant, you can refer to the list of constant values. The wavelength and frequency can be related as lambda is equal to C over nu, okay, which is frequency. Once you get the frequency, you can also calculate the wavelength of that light. The value of speed of light you can get from the list of constant values. Thus, you can combine these two formula, the first one and the second one, then you will get the other formula, which is delta E equal to Hc over lambda. So this, the third formula, showing the relationship between the delta E or wavelength. These are the formula in chapter 2 that you have to memorize them. The other formula, we call it as Rydberg equation. So wavelength emitted by the transition of electron between two energy levels is calculated using Rydberg equation. Rydberg equation is the formula that you can use to directly get the value of wavelength. If the question gives you the transition of electron and the question asks calculate the wavelength, so you can use Rydberg equation to directly calculate the wavelength of the transition. Compared to this formula, boleh juga you dapatkan wavelength, tapi kerja dia macam banyak. You have to find the delta E first, kemudian you use the other formula to get the wavelength. Therefore, my advice is, if the question give you a transition and ask the wavelength, it will be easier for you to only use Rydberg equation to directly get the value of wavelength. Ada je pelajar dia lebih selesa untuk cari delta E dulu baru wavelength. Tak ada masalah. Okay, cuma you have to read the question carefully because sometimes the question specifically asks to use Rydberg equation to calculate the wavelength. So, bila soalan memang betul-betul minta Rydberg using the Rydberg equation, kalau you gunakan formula ini to get the wavelength, you takkan dapat markah calculation. You might get final marks, but not jalan kira you. Alright? So that's mean you have to read the question carefully. So that's why I said if the question give you a transition and directly ask you the wavelength, it will be better if you use Rydberg equation. As you can see, Rydberg equation punya formula ni is ada similarities with the formula delta E you belajar in the first video. Kalau kita boleh recap balik formula from the first video to calculate the delta E, the formula is delta E equal to RH 1 over N initial squared minus 1 over N final squared. Okay, so formula at the bottom is for you to calculate the delta E. Okay, kalau Rydberg equation, samanya kat sini ada RH dan juga ada bracket kat sini. Cuma dalam bracket RH itu, instead of gunakan N initial and N final, digunakan N1 and N2. Okay, and also dia ada condition. Condition tu maksudnya the value of N1 must be smaller than N2. That's the condition if you want to substitute the value of N1 and N2. For delta E, to substitute the N initial and N final, it depends on the movement of the electron from which energy level to another energy level. But if you are using Rydberg equation, it doesn't matter, okay, dari mana ke mana, yang penting N1 dia must be smaller than N2. So you substitute into the formula. Okay, kat depan ni kita ubahlah 1 over lambda dengan delta E. Kita nak wavelength. Ini yang kita nak. Okay. Other than that, the difference between these two formula is the value of Rydberg constant. I did mention in the first video, there are two values of Rydberg constant. So please refer to the list of constant values that I gave you. Rydberg constant, using in the delta E punya formula, it has unit joule. Okay, but for Rydberg equation, the value of Rydberg constant that you use mestilah unit meter. Tak perlu hafal the value. You just kena pandai nak pilih value of Rydberg constant based on list of constant values. Sebab kenapa this one guna meter? Because you want to find lambda, wavelength. So wavelength unit dia dalam meter. That's why you choose Rydberg constant with the unit meter. On the other hand, for delta E, you are using Rydberg constant with the unit joule because the unit for energy is joule. So you have to make sure you tidak tersalah masukkan nilai Rydberg constant. The other thing that I have to remind you is when you write the formula of Rydberg equation, the formula bukan sahaja setakat sampai box ini. That's why madam labelkan juga this box. Condition ini juga is a part of the formula. If you didn't write yang bahagian condition N1 is more than N2, you tidak akan dapat markah formula Rydberg equation. Okay, I hope that one clear. So let's practice. Okay, calculate. Calculate the frequency, wavelength and energy associated with the line with the shortest wavelength in Balmer series. First, you keluarkan apa yang soalan nak or what information given in the question. The question asks three things: frequency, wavelength and energy associated. Okay, so frequency, wavelength and delta E. Okay, this is what the question asks. Frequency, wavelength dan energy associated tu adalah pada line. Line ni hanya akan terhasil bila electron drop from higher energy level to lower energy level. Okay, ingat, line can only form when the electron move from higher to lower. Electron move from lower to higher, tak ada line terhasil. Okay, I did explain in the first video how to form the line spectrum. Line spectrum yang terhasil bila elektron jatuh. Elektron yang atas tak ada line. Dan line itu adalah is the shortest wavelength. Okay, ini persoalan. Macam mana nak cari the shortest wavelength? Another information given is a Balmer series. So definitely, elektron tu akan jatuh daripada n equal to tak tahu kepada n equal to berapa. Give hint that it is a Balmer series, maka elektron tu akan jatuh dekat n equal to 2. Which energy level the electron fell from? Berapakah nilai ini? Dan clue dia adalah pada shortest wavelength. So now, I would like you to think and give me the answer. N equal to berapa elektron tu asalnya berada sebelum dia jatuh kepada n equal to 2. To answer this question, Meda nak recap balik energy level diagram. Ingat tak? Energy level diagram, contohlah. Ni adalah energy level diagram contohnya kan. So ini adalah energy. Semakin besar gap jatuhnya dia, semakin besarlah delta E, betul? Relationship antara delta E dengan wavelength. Dengan wavelength ni. Sebab kita nak cari shortest wavelength tu sebenarnya yang kat mana? Okay. Berdasarkan formula on previous slide, delta E is Hc over lambda. Dia kata shortest wavelength. Shortest wavelength means lambda ni sangat kecil. So, bila lambda ni sangat kecil, delta E ni mesti sangat besar. Itu bermaksud gap antara dua ni mesti sangat jauh. Mesti sangat jauh to get the delta E. Okay, awak dah belajar previous video. Okay, semakin besar jarak perjalanan elektron tu daripada atas ke bawah tu, semakin jauhnya jarak energy level elektron tu bergerak, semakin besarlah delta E dia. Maksud medium adalah, contoh awak ada energy level sini ke sini. Delta E dia tidaklah sebesar delta E ini. A dengan delta E B. Okay. Semakin jauh perjalanan elektron, semakin besarlah delta E dia. Okay. So delta E B ni mesti lagi besar daripada delta E A. Sebab dia punya movement dia jaraknya jauh. Okay. Oleh kerana dia cakap the shortest wavelength, dia tak bagi tahu pun clue nombor dia berapa, maka jawapan kepada N yang ini adalah infinity. Sangat jauh, tak tahu. Sebab dia kata the shortest. Clue dia adalah the shortest. Itulah N initial dia, asalnya dia berada di mana. Ada lagi satu soalan. If this question, Mary ubah sikit, cari frekuensi, wavelength, energy associated untuk line, the second line of Balmer series. Itu maksudnya elektron tu bergerak dari mana ke mana. Itu bermaksud kalau second line Balmer series confirm jatuh dekat 2 juga kan? Confirm jatuh kat 2. Okay. Tapi kalau second line maksudnya dia N equal to berapa? N equal to berapa kepada N equal to 2. When electron fell from N equal to 3 to N equal to 2, dia akan keluarkan satu cahaya dan line ini adalah the first line. Second line adalah bila elektron tu jatuh daripada N equal to 4 kepada N equal to 2. Cahaya yang keluar itu will be the second line. Yang paling rendah dia jatuh, paling kecil delta E dia, itulah dia punya first line.